And moving on into the second half of our notes on 6.1, this should be shorter than what we were working on before. This is where your book decides to introduce the concept of rational exponents. And I want to remind everybody, or maybe teach you for the first time right here, when mathematicians use the word rational, they're really just talking about the word fractions. There's a more complicated definition to it right there, but if you in your head can link the word rational and fraction or fractional, you're going to be fine. So fractional exponents is something we start talking about here in chapter 6, and I believe it's something you guys haven't really dealt with before. Maybe you got this introduced to you 2 years ago in Algebra 1, but you might have well forgotten it even if you did. Okay, so just a little bit of definitions and explanations right here. What does it mean if you have a number, a, raised to a fractional exponent like 1 over n? Well, that fits right in with what we were just talking about here before. A fractional exponent can be rewritten with a radical. Now the radicand, the number under the radical, is just going to be the base of your exponent here, which is going to be a. And then, if your exponent here is a fraction with a 1 on the top, then the denominator of that fraction, which in this case is n, becomes the index of your radical. Okay, so just a quick example of that, guys. If I were to ask you all, hey, what is, let me go with this one right here. What is 512, let's see if I'm doing this right, raised to the 1/9 power? Well, that would mean, all right, let's take a look. I could rewrite this as a radical. The base, 512, is my radicand, and the denominator, 9, is going to be my index. The 9th root of 512. And I think I picked one here where this actually works out. Let's check this, guys. I guess I could do this 2 different ways. I could do 512 raised to the 1 divided by 9 power. Oh, and that gives me a nice answer of 2. But I think I could also do my nth root button. Again, for you guys, it's the math button and then number 5. And I think I could have also typed in the 9th root of 512, and I should get the exact same answer there, and I did. All right, so that's just an explanation of what a fractional exponent means. Now, right next to that, over here on the right, guys, it's the same basic setup, but just a little bit more complicated. This is what you do now if the numerator is something other than 1. It is still going to be rewritten with a radical. A, the base of your exponent, is still going to be the radicand. N, the denominator of that fraction, is still going to be your index. But the numerator of that fractional exponent, which in this case is m, is an exponent that's acting on the radicand of a. And there's actually 2 different ways you can write this. This is perfectly correct, what I've done right now. Now that implies, though, guys, that you would take a to the m power and then take the nth root of that result. And that will work. But another way to do it that's actually probably smarter is to take, let me get this written out correctly right here, still going to have a radical right here. It's still going to be the nth root of a, but you could put parentheses around all of that and then take the result to the m power. So I like this second way better because it encourages you to take the nth root of a first, which is going to make all of your numbers smaller, and then take that small number to a power. If you do it this way here, guys, you're going to end up with some ridiculously large numbers by taking a to the m power first, and you're basically forced to use your calculator at that point. But if you do it this second way down here on the bottom, and you know some of those powers out there, like perfect cubes or maybe even a few perfect fourths or fifths, this opens the door to you guys being able to do the problem, at least in theory, without a calculator. So I really like this second version here better than the first, but either one of them will work. Okay, either one of them is correct. So let's see that concept in action here, guys. 625 to the 1/4 power. Now, again, you could just type this into your calculator and it will tell you the answer. But I'll warn you guys, we're going to be taking quizzes and tests in this chapter, at least part of which is going to be non-calculator. So we need to know what to do with this. All right, fractional exponents. So we rewrite it with a radical. The 625 is our radicand. The denominator of the fractional exponent, which is 4, is our index. That goes right there. The numerator of that fractional exponent, which is 1, is an exponent, but there's never any point writing an exponent of 1, so I can just quit right there. And now I'm looking for some number times itself, times itself, times itself again that equals 625. Okay, and I think you guys could probably just play around with this one for a while. Since the number ends in 5, there's a very good chance the answer ends in 5, and I do believe it's 5. Let me double check that, kind of doing it the right way. 5 raised to the 4th power. Yep, sure enough, that was 625. So here you go. Our answer to example A is 25. And that's it. 625 is a perfect fourth. We haven't talked about that at all yet. So for that reason, the answer is an integer, and there's no radical left over at the end. Whew, how about this one? 973 to the 1/5 power. So my question now is, how do I rewrite this? I rewrite it with a radical. 973 is my radicand, and the denominator of that fraction, 5, is my index. Okay, so I'm looking for numbers here, guys, or a number that raised to the 5th power would equal 973. All right, well, given that the radicand is odd, I don't think my answer is going to be an even number, because an even times itself is another even. And if you keep multiplying that by evens, guess what? You keep getting even numbers. So my answer here, if it's a whole number, would have to be odd. So I'm going to just work forward. In my calculator, and I'm just going to try a few things. What's 3 raised to the 5th power? Does that get us what we needed? Nope, 243. That's not it. Again, we know it's not 4. I'll go ahead and verify that. But an even number raised to any power, is always going to be even. I just realized something. 4 to the 5th was 1,024. That's too big. We're looking for the 5th root of 973. So 3 to the 5th was too small. 4 to the 5th is too big. What that tells me then, guys, is that this answer right here is going to end up being a non-integer value. And I don't think this one simplifies either, so I think my intention with this problem was just to have you go to your calculator, and type that one in. So again, for you guys, I'd hit Math 5 and then do the 5th root of, I forgot what the number was, 973. And let's see what we get there as a decimal. So again, your calculator would give you this. Okay, and we'll round that to the nearest hundredth, everybody, and write 3.96. Okay, so that's what we're going to write for this, 3.96, and we'll have to call it good at that point. Not sure that's a great example I gave you right there. I don't think you're going to see too many problems like that on your homework or on your test. C's a more interesting example. -8 raised to the 2/3 power. And notice the -8 is in parentheses. So we're going to rewrite this rational exponent with a radical. All right, the base of that radical, the radicand, is going to be -8. That's going to go right here. The denominator of the fractional exponent, 3, is our index, and the 2, the numerator, is going to be an exponent. Now, I could put that 2 right here, but I think that's a bad idea for the reasons I talked about before. What I think is smarter is to put parentheses here and evaluate, if we can, the cube root of -8 first, and then square that result. So here we go. Is 8 a perfect cube? Yes, it is. 2 times 2 times 2 is 8. And because it's negative, our answer there is going to be -2. -2 times -2 is 4, multiplied by another -2 is -8. So the cube root of -8 is -2. We're now going to square that. And remember, everybody, that a negative number squared, a negative number times itself, okay, here we go, is going to equal a positive, and we're going to end up with +4 for the answer to that one. Now, again, you could verify this on your calculator. You could put in parentheses -8 and raise it to the 2/3 power, and your calculator will give you that same answer of 4. But I'll warn you guys, this is a question that would show up on a quiz or a test in the non-calculator section. So you do need to know how to do that by hand if you care about getting that problem right, which hopefully you do. All right, last example on this page, 25 to the 5/2 power. Okay, what are we going to do? Not that. All right, we're going to rewrite this with a radical. Your radicand is the base of the exponent, 25. Then the denominator of the fractional exponent 2 is our index. So I could absolutely put a 2 right here, but as I told you guys in the previous video, you never have to write an index of 2. It's implied, so it's kind of like putting an exponent of 1. But speaking of exponents, the numerator of this fractional exponent 5 becomes an exponent over here on the right. And you could put the 5 right here, but oh boy, now we need to take 25 to the 5th power, and that's a ridiculously large number. 125, 625, I think it's something like 3125, but don't quote me on that. What's a much better idea is to do the square root of 25 first and then take that result to the 5th power. And luckily this is pretty easy here. The square root of 25 is just going to be 5, and then that is going to get taken to the 5th power as well. So, isn't this where I was just a second ago? Oh, I'm sorry. 25 to the 5th power is what we would have needed before. That is way too big for me to do in my head. But anywho, 5 to the 5th. Yeah, this is one I'd give guys a calculator for. I think I said 3125. Yeah, that was it. All right, and there we go. So a 3125 for the answer. I do just want to point out something about these last two problems right here. So for C, just for the time being, let's ignore that negative right now and let's pretend it's not there. I want you guys to look at what's going on here. We took 8 to a fractional power of 2/3 and we got a result that was smaller than the base that we started with. The reason for that, everybody, is because your exponent, 2/3, is smaller than 1. Okay? 8 to the 1st power, let me write this up here, 8 to the 1st power is just 8, the number itself. 8, nope, that's not what I wanted. 8 to a larger power, like, oh, I don't know, 8 squared is going to be a number bigger than 8, 64. But 8 to a fractional power, something smaller than 1, is going to give you a result smaller than 8. And that's how we ended up with 4. But if you take a look at example D, we took 25 to a fractional power, but that power is bigger than 1. So 25 to the 1st power would just be 25. 25 then to a power bigger than 1 would have to be a number bigger than 25, and that's how we got 31.25. So that's maybe just a little something to remember right here as we move forward, guys, that if you're taking a number to a power smaller than 1, your answer has to be smaller than what you started with. And if you're taking a number to a power greater than 1, then your answer is going to be greater than what you started with. Okay. Let's go to this next page right here. I got to zoom in. All right, and the last big concept we're going to talk about here, guys, how do we solve equations using radicals? All right, so basically here, guys, let's take a look. This is something you haven't seen before. X to the 7th is equal to negative 532. Our goal in solving an equation is always the same. Get x by itself. Or put another way, find what's being done to x and undo that. And whatever you do to the left side of an equation, you do the same thing to the right. So ask yourself in this question, even though this is something we have never seen before, where is my variable? Well, obviously right there. And what's being done to it? It's being taken to the 7th power. And now, how do I undo that? Well, you've seen a little bit of this before. We've done problems this year where you had something like x squared is equal to, I don't know, 121. How do you undo a square? With a square root on both sides of the equation, and you'd end up with x equals 11, and you'd be done. Same concept right here, except just a little bit more complicated. How do I undo a 7th power? Well, wait a minute, let me take that back. You undid a square with a square root. You're going to undo a 7th power with a 7th root. So we're going to take the 7th root of both the left side and the right side here as well. And that 7th power and the 7th root simply cancel each other out, and we just get x on the left. And then the 7th root of negative 532, I think I'm going to need my calculator for that one. So let me try that. Again, for you guys, you're going to type in math and then 5 and get to something that looks like this. And the 7th root we said of, I forgot the number, negative 532. Oh, what am I doing here? All right, negative 532 is what we need there. Okay, and Yeah, that one ended up being a decimal. That's okay. Negative 2.45 is going to be my answer to this problem. So certainly, guys, sometimes you're going to end up with irrational answers and ugly decimals, and that'll happen. But anyway, that's how you do that one. Two more examples, and then we're out of here. This one I like because it kind of harkens back to something we did earlier in the year. You'll notice that this equation only has one x in it, but a lot is happening right here. By order of operations, the first thing happening to x is what's in the parentheses. So they're adding 3 to x first. Then, what happens to the x plus 3? Exponents happen before multiplication. So taking something then to the 4th power is what happens second, and then multiplying by negative 4 is what happens last. These are the 3 operations we need to undo to get x by itself, and we undo them in the opposite order that they were happening. So this multiplication of negative 4 is the first thing we have to undo. How do you undo multiplication? You divide both sides by whatever that coefficient is there, and here we go. This negative 4 and that negative 4 cancel, so we now have x plus 3 raised to the 4th power is equal to, and I don't think I was very nice to you guys here, 70 doesn't divide by 4 evenly. Negative by negative is positive. That's going to be a positive 17.5 if I'm not mistaken. Let me check that real quick, guys. Negative 70 divided by negative 4 is equal to, yep, 17.5. Okay, so we took care of the multiplication. The next thing we have to take care of is the 4th power. And how do we undo a 4th power? With a 4th root. So you can do it that way, or you really could do a 1/4 power on both sides, but either one is fine. So those 4's cancel out. And we end up with x plus 3, I really don't need those parentheses anymore, equals, all right, guys, and I'm sure this one's going to be a nasty decimal, the 4th root of 17.5. So again, you guys are going to hit math 5 and do the 4th root of and 17.5, although really just hitting last answer would have been faster. Okay, 2.05 if I rounded that to the nearest hundredth. But don't hit clear on your calculator, guys. 2.05, and we took care of the 4th power. The last thing to get rid of is the plus 3, so we're just going to subtract a 3 from both sides. Those cancel out, and we're going to get x equals. Now again, guys, do not manually type 2.05 into your calculator. You already have it there. Just hit minus 3, and last answer will pop up, and this is the accurate answer I was looking for, negative 0.95. Okay. Negative 0.95, and that's our answer. Obviously, if your directions told you to round to something different, like the nearest thousandth or 10,000th or something like that, that's what you would follow. But usually in Algebra 2, without hearing something different, we round to 2 decimal places. Last problem I wanted to give you right here, x to the 7/9 is equal to 128. How in the world do you get rid of a fractional exponent like 7/9? Okay, the key here relies on an idea that I haven't really talked about in these notes at all, and I'm going to write this at the bottom, guys. If you're taking a number, a, to a power, let me just say a to the b power, and all of that is getting raised to another power, a to the b raised to the c power, this is when you multiply your two exponents together. This becomes a to the bc power, and remember that bc means multiplication of b times c. Now here's why that's important. This is actually a really easy problem. If you want to get rid of a fractional exponent like 7/9, you're going to reciprocate that exponent, which is going to be 9/7, and apply that new power to both sides of this equation. Now, why does that work? Because of the trick that we just talked about down here. A power of a power is when you multiply your exponents together. So back up above here, this means that we're going to multiply 7/9 and 9/7 together. Well, the whole point of reciprocals, guys, is that when you multiply them together, the 7 on the top cancels with the 7 on the bottom, the 9 on the top cancels with the 9 on the bottom, any number times its reciprocal is just equal to 1. So we end up with x to the first power, but there's never any need to write a first power. You can just write this as x. Now from here, You guys are probably going to say we could go to the calculator right here, and you probably could, but I could rewrite this with a radical. 128 would be my radicand. The denominator, 7, is the index. And then I would take that whole result, if it worked out nicely, to the 9th power. And I'm pretty sure, guys, 128 is a perfect 7th. I think it's 2. Let's try it. 2 times 2 is 4, times another 2 is 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th, then, is 64. And 2 to the 7th is 128. So the 7th root of 128 is 2, and now I need to take that to the 9th power. And that sounds hard to do, but I've already got most of it right here at the bottom, guys. 2 to the 7th is 128. So if I multiplied 128 times 2, that gets me to 256 times another 2 again. That gets me to 512. So nobody except nerdy Mr. Fontana or other math teachers out there, I suppose, is going to actually do that work by hand. You guys probably would have just dumped this into the calculator, right? Better yet, you probably would have put this into the calculator and gotten the exact same result. Let me remind you guys, 9/7 is a power bigger than 1, so we ended up with a result bigger than 128. All right, guys, that's everything I got for you from 6-1. So hopefully that gives you a good firm footing now with roots and rational exponents and how to use those moving forward. And hopefully the rest of Chapter 6 won't be that bad. Good luck, everybody.